Hello, everybody. My name is Ramzi Jaber. In our paper, we'll talk about how to proposing a ternary multiplexer using CNTFET transistors. Outline, we'll talk about introduction and motivation, objectives, proposed a ternary multiplexer, then simulation result and comparisons, and concluding by conclusion. As you know, the embedded and portable systems have seen a notable increasing in the market, expected more than 50 billion devices by end of this year. It can be implemented almost in everything. The problem of conventional design of the ternary multiplexer has high number of transistors, leading to or results in high propagation delays and energy consumptions. Solution: redesign the circuit to get higher performance and lower transistors count, reducing the propagation delays and energy consumption. Before continue about that, we'll talk as background about what is MVL, multiple valued logic. In binary system, each wire or each bit has two values: low, high, 0, 1. Whereas in ternary logic system, each wire or each thread has three values: 0, 1, 2, low, middle, high. The challenge here in the ternary system, how to get VDD over 2, the middle. For MVL, in general, each wire has n values from 0 to n-1, from low to high. Among all these bases, the ternary systems has most efficient in circuit complexity and cost compared to other bases. That's why in this paper we use ternary logic system. Why we'll use MVL? Because it will reducing the number of interconnections, decreasing the power consumption and propagation delay, then increasing the data transfer and storage. Simple example. In binary system, if we have two modules connected by 8 wire or 8-bit bus, so the total combination of this small system is 2 power 8, 256. Whereas in ternary system, we choose 6-wire bus, only 6 wire. So in the first, we're reducing the number of interconnections by 25% in this simple example. Here, if we calculate the total storage or total combinations, we get 3 to power 6. 3 base 3 power 6 number of wires equals 729. So the storage or the data transfer or the total combination increasing by 185%. Imagine that. Where we can use MVL, memory, SSD, also in flash memory using MLC, triple level cell TLC, using multiple voltage levels. Also in signal processing, using multi-valued PAM in communications. So MVL is now used almost in everything. Also, why we choose this kind of transistor, CNTFET transistor, carbon nanotube field effect transistor. Why we choose it? Because has better performance than FinFET and CMOS, lower power consumption, using low power supply, VDD equal 0.9 volt. Also, but the disadvantage is high cost production. The main advantage here, CNTFET is suitable for MVL because the voltage threshold of this transistor is directly dependent on diameter of CNT, carbon nanotube. So in this paper, we choose two diameter, D1 and D2, to get two voltage threshold, around 0.3 volt and around 0.6 volt. And this table is the operation of NCNFET and PCNFET, when it will be on, when it will be off, for these three voltages. Objectives: decreasing the energy consumption of portable and embedded system, improving the data transmission inside the circuit. How? We'll use in this paper, we'll use in our research, high performance transistor technology, CNTFET, ternary logic system, and reducing the number of used transistors. Now let's begin into the circuit. But before talking about multiplexer, let's talk about the basic element in any digital circuit, which is inverter. Similar to binary inverter, one input, one output. Similar. For low input, we get high output. If input, high input, we get low output. It's the identical same compared to binary inverter. But here's the difference here. What will happen in the middle voltage? In the middle, VDD over 2, what will happen? If the input is equal to 1 middle, what will happen to the output? Remains no change? Get 0, becomes 2, whatever. So here we have three solutions. If still the same, one become still 1, no change, this inverter called standard ternary inverter, STI. If the output becomes 0, this called negative ternary inverter. If the output becomes high, this inverter called positive ternary inverter. So in ternary system, in ternary, we have three ternary inverters: STI, standard, anti-I, negative, PTI, positive. In our paper here, we use STI. We use our previous design of STI. But before showing that, we'll talk about how existing STI works. Here, in these references, A, B, and C, they use diode connected transistor, which is act like resistor, to get voltage divider, to get VDD over 2 in the middle, VDD over 2, here or here or here. This method has this advantage because has high current, which produce high power consumption and high energy consumption, because they use voltage divider, internal resistors. To remove this, we use in our previous design of STI, we remove these two transistors and we use VDD over 2 instead. So we reduce the power consumption, the energy, and increasing the power propagation delay. Now let's talk about ternary multiplexer. In general, ternary multiplexer, 3-to-1 ternary multiplexer has 3 inputs, 1 selection, 1 output. If the selection equal to 0, the output will be the first input. If the selection equal to 1, the output will be the second input. If the selection equal to 2, the output will be the third input. This is T multiplexer, how it's work. Where we can see in T multiplexer, almost in every logic circuit. Application, for example, here in ternary half adder, they use unary operators and multiplexers to get sum and carry from AB. Also here, for ternary multiplier, they use cascading ternary multiplexer, as you can see here. So multiplexer can be used. Existing multiplexer. Here we have 2 references. A, reference 15, B, reference 16. Here we have 28 transistors. They use ternary decoder and transition gates. Here they use, instead of ternary decoder, they designed, the author of 16 designed new unary operators instead of ternary decoder to reduce the number from 28 transistor to 18 transistor. But in our design, we reduce it to 13 transistors. We're using only STI, standard ternary inverter, and transition gates. And we use here cascading transition gates to get 13 transistors, to get better performance. Simulation result and comparison. The proposed circuit and other circuits are simulated and tested using ICECS simulator with 32 nanometer CNTFET, but with power supply 0.9 volt, frequency 1 gigahertz, temperature 27 degrees. The result, this is a table of comparison. We compared with 6 different references, but we choose 16 and 19, the worst case and the best case. Worst case compared to maximum energy consumption, worst case in the energy consumption, best case in the energy consumption. PDP, its power delay product, its energy consumption. So we compare our proposed circuit, proposed ternary multiplexer, with worst case and best case. Compared to 16, we have improvement 27.7%. But compared to 19, it was 12 transistor. Here we have 13. So we don't have improvement here. But we have improvement in the power. We don't have improvement in the number of transistor, but we have improvement in the power consumption. Almost among all these references, more than 55% improvement. This is our goal. Performance of power consumption. About delay, we don't have many improvement. Even in energy, it's not good enough. But we have performance. We have improvement in the power consumption. We focus on the power consumption. So the conclusion will be, this paper proposed a ternary multiplexer with 13 CNTFET that aim to reduce the size of the circuit and enhance the performance of the develop various ternary logic circuit, including ternary logic gates, adders, multipliers, and others. The results of the simulation showed that the advantage of the proposed circuits regarding power consumption over 55% compared to the best design. Thank you for your listening. If you have any questions, please ask.